Okay, so tomorrow's set of notes, we're going to compare fractions some more. One thing, if you're not watching the videos, definitely take some time to look over your guided practice and the assignment part, because today we had a couple of parents coming after school wondering how much was shaded and why their kids couldn't do a certain part of their homework, and it's because the part of the homework says using your manipulatives. So, I mean, if you had read that or looked at that, you could have caught that and the kids would have done that in class. So just always look over your stuff before you are teaching it, whether it's the video and completing your notes as the video plays, or like I know when I'm really late some nights, if you can't watch it in the morning either, I understand. I'm really rushed in the mornings. So, take a copy home or do it or look over it, in the morning in the cafeteria. Just kind of be mindful. So using your manipulatives, we're going to compare. So they're going to build 1/2 and 3/4. And they're going to see that 1/2 is less, 1 dot is less than 2. And then I want them to think through it a little bit. What is half of 4? As in, D denominator says I'm divided into 4. Well, what's half of 4? Well, remember, if you're chopped in half, you're chapped into two. You're chapped. You're not chapped. You might be chapped, you're cut in half, but you're chopped into 2 parts. Well, 4, half of 4 is 2, because 2 plus 2 makes the whole amount of 4. So half of 4 is 2. So the fraction 2/4 is equivalent to a half, because 2 out of 4 is a half. So they're equivalent, which means 3/4 is more than a half. And that's a big thing in 4th grade, is using this benchmark fraction. Benchmarks are fractions easily recognizable to students. If I know half of 4 is 2, then I know 2/4 is half. So 3/4 is going to be more than a half. All right, they're going to build these models. First thing after we build them, we're going to see that 3/4 is greater. 2 dots are greater than 1 dot. Thinking through, both are fourths. Well, what do we call the bottom digit? Denominator. That's right, because we get down and shake our denominator, which is our bottom. So both denominators, D-E-N-O-M, denom, I, nay, N-A, ter, T-O-R-S, plural, more than one. The denominators are fourths. So both fractional amounts are blank into 4 parts. Well, what do we know D denominators say? Yeah, divided into. Which we could also, what are some synonyms for divided? You could say they're divided into 4 parts, split, separated, broken. Any of those would be good. So they're both broken into 4 pieces. Therefore, blank out of 4 is more. Well, if you have 4 pieces of cake, and 4 pieces of cake, 3 versus 1 is more. So 3 out of 4 is more than 1 out of 4. This is where we really saw them struggling, is when they see the numerators are the same. How do we remember that the top digits are numerators? Because we nod our numerator. We're nodding our head. Plural, more than 1. The numerators are 2. The larger the denominator, the blank the pieces. So this denominator says, dude, I'm divided into 3 pieces, as in my set is divided into thirds. This denominator is saying my set is divided into fifths. And if they built these already, which they should have, they're going to see that 2/3 is greater. 2 dots are greater than 1 dot. They're going to see that. So the larger the denominator, so I'd ask the kids, which denominator is larger? Fifths. The larger the denominator, the blank the pieces. Look at the fifths pieces compared to the thirds. What could we say happens the larger the denominator? The pieces get smaller is right. So the larger the denominator, smaller the pieces. Just look at your models. Therefore, 2 out of 3 represents 2 larger pieces versus 2 out of 5. You divide with 3 people, think about dividing cake with 3 people. Your pieces are bigger. You divide with 5 people, your pieces get smaller. So if you're eating 2 from bigger pieces and 2 from smaller pieces, 2 bigger pieces is more. And then we're going to expand on that. So in Morgan, your box, and Karen's box, I have 4 Sour Punch straws for each of you, and some of my scissors. Actually, Morgan, I think your set is short 2 Sour Punch. I have to get more from Amber, but you have enough for your first period anyway. To better understand the third comparison sentence and the thinking through section, so to better understand this, we're going to do something with Sour Punch straws and understanding our denominator. So I would tell the students, I'm not even going to pass them out until we read through this and discuss it. And once I hand the materials out, you're not going to touch them until I tell you to. So one of our Sour Punch one Sour Punch straw will be shared between 2. 1 will be shared between 4. 1 will be shared between 6, and 1 will be shared between 8. And I want all students to go ahead and draw 4 rectangles. What do you think the rectangles are going to represent? The Sour Punch straws. Why do you think it's important that we make them the same size and same shape? Why do they need to be congruent? Well, that would be because in fractions, to be fair, they need to be same size, same shape, congruent. Mine would be a little bit neater. Again, it's trying to video and draw. So I would go ahead and have them do this before you hand anything out. And tell them don't do anything else. All right, so before everyone starts cutting the Sour Punch straws into pieces, what do we know must be true about the fractional pieces? Like up here, when we're looking at fractional pieces, like your models that y'all have drawn, or these models down here, what do you know about the pieces of the thirds, of the 6? Yes, they have to be the same size, same shape, which we would call congruent. So if you're the same size and the same shape, you're congruent pieces. So when we decide to share between 2, we need to make sure that the 2 pieces are congruent. What does that mean? Same size, same shape, good. And then the 4 students, when they share, the fourths need to be congruent. Same size, same shape. Same for 6 and 8. So I'm going to pass 4 kids out a Sour Punch straw. They're not going to be ones yelling at me. They're going to be ones that I know are going to follow directions. And then I'm going to hand them scissors. And we're not going to gripe at all. All right, so then you hand 1 kid 1 Sour Punch straw, another kid. So 4 kids are going to have the straws. And I'd kind of spread it out because you're going to want 1 kid to share with 2 kids. And then you're going to pass out another one to share between 4 people. And then another one to share between 6 and then 8, which is 14, 18. That's 20 kids in all. If you don't have 20, it doesn't matter. And on the Sour Punch straws, I went ahead and drew like little dark marks like this on yours so they know where to cut. So you've got the half, you've got the 4th, you've got the 6th, and then you've got the 8th. So the Sour Punch straws already have this. And I sent scissors just so they can muck up my scissors, not yours. But please make sure I get my scissors back. And so tell the kids, all right, so those of you with the Sour Punch straw, find the little dark black marks. You know, if you're cutting it into 6th, then you definitely should see marks to get 6 pieces. So give it to kids who are good at following directions. So then go ahead and cut through the wrapper, blah, 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 blah. All right, so those who were splitting in the half, take your piece. Those who I told to share the 4th, take your piece. Those who sharing the 6th, take your piece. 8th, share your piece. If you have extra 8s, you take them. All right, before we eat anything, actually I said share them. Ixnay on the airing hay or whatever. Airing shay? Yeah, there we go. Airing shay. Anyway, excuse my pig Latin. Before you split them up, after they cut them, pick up like this set and put it on the overhead. and tell the kids to duplicate. So when you're cut in half, cut it in half. And the 1 1/4, look, there are 4 congruent pieces. So we're going to find half. Where am I at? And then find half of that and half of that. So 1, 2, 3, 4. And then pull up the Sour Punch cut into 1/6 and bring it up. And get them to have 6 congruent parts. And then bring up the 1/8, show it on the overhead. Draw it. And then you can tell the, kid, after you use the halves, okay, if Courtney had the halves and she cut it, tell Courtney to come back and grab them and she and John share. All right, after you draw the 4ths and show them on the overhead, okay, Stockton, come grab the 4ths, and you and Kevin and Landon and Owen share the 4ths. And okay, Karen, come get your 6th after I show them on my overhead. All right, Karen, Tori, Chelsea, Petra, Morgan, Lasagna, y'all share the 6th. And then, okay, Daniel, come get your 8ths after I've used them on the overhead and share with the leftover kids. And then whatever's left, come bring to me. Don't eat them, don't touch them, just share them on their desk. All right, so let's answer some questions for our aha moment. Which Sour Punch straw set has the largest pieces? Let's look at our model up here. Which set has the largest pieces? Yeah, the one with 2. So the one that was cut into, what do we call that? Halves. And if it's plural, the F gets dropped for a V. So the halves are the larger pieces. So I guess I want the straw set largest pieces. And now I want the straw set with smallest. Well, look at your sets. Which one has the smallest fractional pieces? The one divided into 8ths. 8 EIGHTHS, 8ths. So to sum up all these parts that we've been talking about, the blank, a whole, is divided up into fractional pieces. The blank, the pieces will be. So the blank, a whole, is divided up into. The more a whole amount is divided into fractional pieces, the blank, the pieces will be. So the more I divide, the more my denominator grows. Like here's 1/2. Here's that unit fraction. 1 out of 4. I'm D divided into 4. There's my unit fraction of 1/6. D, I'm divided into 6th. 1/8, I'm D divided into 8. The larger the denominator, the more you're D dividing, the smaller and smaller the pieces get. This is backwards of whole numbers. This is why kids struggle with that. But hopefully, anytime you kind of bring up food and, do you want to share with 8 people? Or do you want to share with 2 people? Well, you want to share with 2. Well, why? Because the more you share, the smaller it gets. All right, then I have the whole class read the directions. We're going to use models, compare fractional amounts. So I don't just go shading. Don't get ahead of me because I know you're making hundreds. D, denominators, what do they tell us? We're divided into 7ths. 1, 2, 3, 4, 5, 6, 7. How many should I shade? 7. Yeah, numerator says know what you're talking about. I'm talking about 1, 2, 3, 4, 5, 6, 7. Versus 1, 2, 3, 4, 5, 6. When the denominators are the same, it's easy. 7 pieces out of 7, that's the whole pie. 6 out of 7 is a little bit less. So 7 sevenths is greater. 2 dots are greater than 1. And I hadn't said it, but I would hope at some point, especially after this section, you were up making sure they were drawing this, writing it in. Engagement. That's missing from a lot of classrooms when we walk through. This is things Region Center people, myself, paraprofessionals, different staff members, engagement. If you're not engaging, if you're not collaborating and trying to engage them with interest or funny stories or collaborating, if you're just dryly going through notes or your kids are acting up while you're going through notes, it's noticed and your lesson's just not as powerful. All right, here your numerators are the same. Well, when the numerators are the same, I need to look at the denominator. D, I'm divided into 1, 2, 3, 4. D, I'm divided into 1, 2, 3, 4, 5, 6. The larger the denominator, the more I'm divided up, the smaller, which is true. Look at these 6. They're less than fourths. So if you eat 1 out of 4 versus 1 out of 6, the fourth is going to be more because the less you're divided, the bigger the piece. So 2 dots are greater than 1. And of course, with models, it's easier to see more is shaded than this. All right, a number line. First, we need to name these fractions. So if this is 0, and we call this 1, and this is 0, and this is 1, let's hop along the bottom to find our whole set. 1, are y'all ready? 2, 3, 4, 5, 6, 7, 8. I am D divided into 8. My bottom denominator is 8ths. Over here, 1, 2, 3. My whole set is D divided into 3, which is divided into thirds. Numerator, when you nod your numerator, that end sound, it's know what you're talking about. I'm talking about this guy right here that's circled. That's 1, 2, 3 of the 8 pieces. So this fraction is 3/8. This fraction is 1 out of 3. So we're talking about 3/8 versus 1/3. Well, I can see 3/8 is more than 1/3. So 3/8 is greater. 2 dots are greater than 1. All right, our fraction bars. What do we need to find first, everyone? 2/3. All right, so shade in 2 of your thirds. I'm going to use my pencil for, what's the other fraction? 5/6. So now you're going to lightly shade in 5/6. Doesn't have to be perfect, but it also doesn't need to look like a tornado. You're always faster, so get up and go check on them. All right, I want y'all to put in the comparison symbol. Okay, which symbol did y'all put in? Less than. How did you know it's less than? Yes, 1 dot is less than 2 dots. I agree. 2/3 is less than 5/6. This is less. All right, I want y'all to do this one on your own. I'm going to walk around as y'all are doing this one. Shade it and, fill in the symbol. So I would be going around making sure they're shading the correct amount. The symbol should be less than. And then when you see most of them have completed, and I always go around and go, good job, yes, yours is right, Tori. And then I'd flip it just so their neighbor can't see. And then I go up and actually do it on mine. So I'm going to color 1, 2, 3, 4, 5, 6, 7 of 12. So 7/12. I'm going to color 1, 2, 3, 4, 5, 6, 7 of 10. 7/10. And I can see that this 7/12 is less than the 7/10. 1 dot is less than 2. I already knew that, and this is me thinking through for the kids, because the numerators are the same. And I know that the more you divide a shape, smaller the pieces. If I have to divide my Twizzlers with 12 people versus 10, I'm going to get less when I divide with more people. So I already knew 7 out of 12 was going to be smaller than 7 out of 10. You can even ask them what they think. All right, let's read the direction at the top, everyone. Shade the models to show 2 equivalent or blank fractional amounts. Equivalent, y'all say that word. EQUAL, equivalent. Just a fancy way to say equal, and I would definitely make them say it. Then name the fractional amounts. All right, so now we're looking for equal amounts. So we're going to shade in 2/3. You can do it with your pencil or your highlighters. Sophia, what would be the denominator for my other fraction over here? 6. How did you know that, Sophia? Because there's 6 pieces. That's right. And my D denominator says I'm divided into 6. Very good. I want y'all to look at the 6th. How many of these do y'all think I need to color or shade to be equal or equivalent to 2/3? 4, I agree. So let's shade in 4. And I would tell the students, you can shade in any 4, but it's always smart to try and do the same area. If they're doing the left side, you do the left because it's easier to compare. And here I can see same amount. Different numbers, but equivalent in size. If Kevin eats 2 of his 3 pieces of candy, but Catherine eats 4 of her 6, they still eat an equal amount. It's just that Catherine's bites were smaller, but by the time she ate 4, she ate the same amount as Kevin. Okay. Timoteo, what do you think my denominator should be for this fraction? 8, that's correct. D, I'm divided into 8. All right, well, how many should we shade over here? 1. Peyton, what do we call a fraction with a numerator of 1? A unit fraction. Very good. Let's label this unit fraction, because we're talking about 1 unit at a time. This is 1/4 plus 1/4 plus 1/4 plus 1/4. And I would, of course, be dojoing them if they're answering correctly. All right, I want y'all to look at the 8s. I want y'all to think for a second on how many I should shade to be equivalent to that 1/4. Okay. All right, together, how many do y'all think I should shade? Say it. 2 is correct. If we shade 2, this size is equal to this. They're equivalent. So 1/4 is equivalent to 2/8. If this was a pie or a brownie pan, and Tori divided hers into 4 parts, and she ate 1, and Morgan D divided her brownies into 8, and she ate 2, they ate the same amount. It's just that Tori has a big mouth and stuffed a whole quarter in her mouth at one time. All right, now we're going to use fraction bars. What should we shade? 1/3. All right, let's shade in 1/3. And what are we wanting to find it equivalent to? 9ths. Well, fraction bars I really like, because if you use your highlighter, you can see that we're shading 1, 2, 3. 3/9. Okay, let's do the next one. What should we shade? 1/2. Yeah, 1 of 2. And I'm going to use this segment right here. How many 8ths do we need to shade to be equivalent? 4 is correct. Half is equivalent to 4/8. Now, I already knew that if you're listening, because if you're chopped in half, hi-ya! 4 plus 4 makes 8. I want y'all to do the last one by yourself, and I'm going to walk around. So you should see them shading in 2/3. I'd brag if I saw kids pulling the segment down like you taught them. I always brag if I see them doing the same thing. And then their answer should be 4/6. And then after I walk around, I go back to the overhead and show it. All right, let's read the next direction out loud. So our multiplication table can help name equivalent fractions. What does it mean if you're equivalent? Equal. It's cool, huh? So here's my multiplication table. So when you have 2 fractions, this one we don't know, right? We know the numerator, but we don't know the denominator. Well, we're always going to start with the smaller numerator. So how do we say this fraction? 2/5. So we're going to go to row 2 and row 5. So we're going to row 2 and row 5. 2/5, right? 2/5. And we're looking for a numerator of 6 along the 2 row. So again, 2/5. Well, that's 4/10. 6/15. There it is. 6. What was missing is 15. So 2/5, you keep going down the row, is equivalent to 4/10, which is equivalent to 6/15. So we're going to fill in the 15. Now we're going to add in today why it's equal. Well, if you're using a multiplication table, guess what you're doing? Multiplication. And what is multiplication? It's repeated addition. So 2/5. You're repeating 2. Well, I guess I should count 0, huh? Well, you're repeating 2 1, 2, 3 times. If you're going to jump 1, 2, 3 spaces on the 2's, to be equal, you better jump 1, 2, 3 spaces on the 5's. 2 times 3 is 6. And what you do to the numerator, to be equal, you better do to the denominator. 5 times 3 is 15. So I can use my multiplication table, or if I'm good at multiplication, I could just multiply. All right, what are we going to look for? I'm going to look for 1/3. 1/3. That means I'm going to row, and I would write this a few times, row 1 and row 3. And we're going to have to look along row 3 for the number 6. So 1/3. And I'd go ahead and move here. So 1/3, 1/3. Across the 3's, we're looking for 6. Well, here it is. And what's above it is a 2. 1/3, 2/6. So we're going to write in 2/6. Well, why are these equivalents? Why are equivalents on a multiplication chart? Because if you're being equal to the numerator and denominator, you're finding equivalents. If I jump 1, 2, 3 spaces on the 1's to be equal, I'm going to jump 1, 2, 3 spaces on my 3's. Or 2 spaces. 2, 1, 2, 2, 6, sorry. That's because 1 times 2 is 2. And the rule is whatever you do to the numerator, you better do to the denominator, because that's equal, it's fair. 3 times 2 is 6. Pretty cool, huh? All right, what rows do I go to, y'all? 3 and 5. Very good. We're going to row 3 and row 5. So I want y'all to write that. All right, and which row is going to help us? Is it row 3 or row 5 that we need to be looking across? Row 3, right, because we have the numerator. We want 3 to become a 6, right? So here's my 3/5. 3/5. Going across the 3 row, there's the 6. What's under it? 10. 3/5 is equivalent to 6/10. Why is that fair? Well, if you jump 1, 2, 3's, if you jump 2 3's to be equal, you better jump 2 5's. That's why you're finding equivalents. 2 groups of 3 is 6. And to be equal, you better find 2 groups of 5, which is 10. So if you can use a multiplication chart, you can find equivalents just by multiplying. All right, what rows are we going to go to? Row 1 and row 4. And we're going to use our denominator to get to 28. So 1/4. Let's move across. 1/4. I want y'all to read the fractions as we come across. So 1/4, 2/8. I hear some of you, 3/12. Good, keep going. 4/16. 5/20. 6/24. 7/28. There it is, the 28. What's above it? 7. Why? Why is that equivalent? Well, because on the 1/4, we jumped 1, 2, 3, 4, 5, 6, 7. We jumped 1 7 times. To be equivalent, to be equal, we have to do the same thing with our 4s. 1, 2, 3, 4, 5, 6, 7. 7 28s. What you do to the numerator, if you find 7 groups of 1, you have to find 7 groups of 4. So 1 group of 7 is 7. 4 groups of 7, 28. All right, on this one, what rows do we go to? Row 5 and row 7. Very good. What are we going to be looking for? 21 where? On row 7. So 5 sevenths. 5 sevenths. So moving over, we have 5 sevenths. What's the next equivalent fraction to 5 sevenths? 10 fourteenths. Good. What's the next set? 15, and this is weird, 21st. There's your denominator of 21. What's above it? 15. Well, that's because 1, 2, 3 5s. If you jump 5 3 times to be equivalent, you better jump 7 3 times. 5 3 times in a row is 15. 5, 10, 15. To be equivalent, to be equal, you have to do the same thing with the 7. What you do to the numerator, you better do to the denominator. That's the fraction rule. Now, I want y'all to cover your multiplication chart with your paper. And let's try to think. We don't have denominator to denominator, but we do have numerator to numerator. 5s. How many groups of 5 makes 30? Let's count by 5s. 5, 10, 15, 20, 25, 30. So how many 5s did that take? 1, 2, 3, 4, 5, 6. 5 times 6 is 30. And if I'm using times 6 with my numerator, I better use times 6 with my denominator. Now this one is a rhymer. 6 times 8 is 48. So kind of showing them that they don't have to use a multiplication table, which is going to take them down here. I want 4 equivalent fractions for these. The halves, let's write 1/2. Halves should be the easy part. If I told y'all the denominator was 6, what's half of 6? 3. Very good. Can someone give me another half? 5 tenths. Very good. 5 is half of 10. 2 fourths. Very good. 2 is half of 4. Yes, 10 twentieths. 10 is half of 20. Nothing's wrong as long as it's a half. 1/8. That one's a little bit harder. Well, here's what I know. Let's look back up here. Where did we find equivalent fractions at? The multiplication table. And a multiplication table is showing us what? Multiplication, right? And what does the rule say? Whatever you do to the numerator, you better do to the denominator. So to find an equivalent, I just really need to say, let's see, we're good at 2's, right? What's 1 times 2? 2. And if I multiply by 2 to the numerator, I better do that with my denominator. What's 8 times 2? 16. Okay. We're really good at multiplying by 5's, right? What's 1 times 5? 5. And if you're going to jump 5 spaces on your 1 row, you better jump 5 spaces on your 8 row. What's 5 times 8? 40. So 1/8 is equivalent to 5 40ths. I'm really good at tens too. 1 times 10 is 10. And if you're going to jump 10 groups of 1, to be equal, you better jump 10 groups of 8. 8 times 10 is 80. You know what else I'm good at? Those 11s. If I'm going to do 11 groups of 1, to be equivalent, I better do 11 groups of 8. So what you'd have is 11 88ths. So what you're showing the kids is you can find equivalents as long as you're being equal to the numerator and equal to the denominator. Their assignment looks the same pretty much. There is a writing prompt on it. We talked about that. Make them do the writing prompt on the notebook paper first. I would definitely read it out loud to them, but then let them know you can't help them. But they need to show you what they've written, because Telepass quickly says if it looks rushed or not quality work, they need to, do quality work. But anyway, this is tomorrow's set of notes.